Hello, everyone. Thank you for coming to our monthly webinar. This month, we have a great speaker, Dave Wells, who's ready to impart a lot of knowledge. I'm Carlos Bassi, and I'm going to be a participant in this webinar. I'm also the CEO of Datalere, and Dave is going to talk about semantic data layers and the case for a semantic data layer as an architectural component. I'm with Datalere, and Datalere is a data solutions company. We make it easy to use data when your data is complex and difficult. We build systems that put the data at your fingertips and give you what you need when you need it. The next slide has a sample of our clients over the last several years, and then the next slide is where I'll show you our speakers. Dave Wells is our primary speaker today. He's an infocentric consultant. Dave has many years of data architecture, data modeling, data governance expertise, and data strategy, all sorts of different things. Michelle Gadke is manager of solutions engineering at Datalere, and she's going to be our host today. And I'm Carlos Bassi. I'm also not just the CEO, I also function as our chief data architect at Datalere. So I hope we have a great session, and please ask us any questions along the way if you have any. Michelle, can you take it away?
Sure, thanks, Carlos. I'll bring it to the agenda that Dave has laid out here for us. We'll get started by talking about the role of semantics in data management and get into the details of what a semantic data layer actually is, followed by some modeling and architecture. Then talk a little bit about semantic layer implementation and best practices. And I'm really excited to join this crew here and learn something from a few guys who've been doing this for a really long time and have a breadth of experience. So before we get started on the roles of semantics, Dave, just to level set the audience here, a lot of people in the audience might think of a semantic model inside of a BI tool when they think of a semantic layer, such as like the Power BI semantic data set, Tableau Looker. But I think you're going somewhere else with this. So could you kind of bridge the gap on that disconnect we might have?
Sure, absolutely. Semantic layer as a technology component is only a small part of implementing true semantic layer. And the reality is one semantic layer isn't enough for the way we need to manage data today. And semantic layer, just as something embedded in a BI tool, isn't enough. So we need to step back and look at it in a bigger picture as what is semantics? How do we frame semantics as assertions of fact about the real world that's represented by data? And then how do we present those assertions of facts in various contexts for data interoperability, for intelligent AI that doesn't go off the rails, for just having meaning travel with data. So many things that don't happen inside a BI tool. So we need to think of the semantic layer as an architectural component before we think of it as a piece of technology.
And looking at this list, you've got like a range of technical from like integration, interoperability to almost cultural things like reducing ambiguity, improving trust. So if a team could justify just one of these to get a budget approved for where to start, where would you look first?
Okay, I would look, depending on the organization, in one of two areas. For most organizations, I'd look first at data interoperability. And the reason is because interoperability is an alternative to copy-based data integration that doesn't carry around the complexities and the technical debt. When we do copy-based integration, we're doing ETL processing, extracting data from sources, transforming it in various ways, fitting it into a rigid schema, in a data warehouse, or perhaps a more flexible schema in a data lake, but still we're making copies of the data, and each of those copies may be inconsistent with other copies we've made. And then when we have schema drift or schema change or encoding change at the source, we have to do all that impact analysis and figure out which transformations need to change. And that's just getting data from operational systems to analytical systems. If we think about what goes on inside the operational world, we have SaaS applications, we have ERP applications, we have legacy systems, all trying to talk to one another, and they do that through point-to-point data feeds. We have a tangled mess of point-to-point data feeds, and every time something changes, we have to try to figure out where in this tangled mess are all the impacts of those changes. Okay, so we can put a semantic layer in place that becomes the translator that lets an application with one dialect, one lexicon, talk to an application with another lexicon by both of them being mapped to that common semantic layer. So I would make the case for data interoperability as reducing technical debt, giving us greater agility, more flexibility. So that's one place I'd go. The other place I'd go, which isn't explicitly listed here, but is critical in shared meaning, is AI. We're seeing more and more organizations pursuing AI. And as they pursue AI, they really need to make sure that the information they provide to those AI models is not just correct, but also complete. Let me give you an example. I ask AI, I need to wash my car. The car wash is only 4 blocks from my home. It's a beautiful sunny day. Should I walk or drive? The AI model tells me I should walk because I'll have a pleasant walk and save gas. Because the information I gave it, the assertions, the semantics, didn't tell it that I can't wash a car that isn't there. Okay, so the AI model can only act. We personally know that I can't wash a car that isn't there. The AI model only knows what you tell it. And what you tell it comes in the shape of semantics. If I have an assertion that says car washing requires a car, then the model behaves differently than if that piece of information isn't there. So I guess those are the two places I'd look to make a case: are data interoperability or well-informed AI models.
Okay, I love that answer. And Carlos always says, you cannot break the rules of math or physics when you're thinking about AI. So, yeah, a human would know if that car doesn't exist, you can't wash it. AI isn't going to be able to magically make a car appear. So,
Right, and AI isn't going to know that it needs the car unless you tell it so.
yep. Great. Carlos, any differing opinions on that? Would you also start at interoperability and informing AI models?
I would ask, I think there's a big debate right now, as to where the data lives when you do work like this. Does it live at the source, or does it move like Dave said in the past? Often the data has moved to a centralized location, and there's often reasons for doing one or the other, or both. But I would ask Dave, on the interoperability solution, does a semantic layer become a little bit like the old virtualization layers that we were trying to do years ago, but didn't get a lot of momentum, but essentially a better version of that now that it'll actually make it work better than it used to?
The semantic layer has some similarities to virtualization. Um, it doesn't necessarily have to work through the layers of abstraction that the virtualization tools do. Uh, virtualization tools need to have a layer that connects to the source, and then a layer that does any integration consolidation, and then a layer that delivers a view in business context or application context. with data interoperability, I can do it with a single layer. And what I need is the mapping of each element that needs to interoperate, each application or each database that needs to interoperate. I need the mapping of them to that common semantic layer, but I don't need multiple layers in that heavy lifting between query and response that's so common with the virtualization tools.
Sure, I got it.
Great. Let's move on to the next slide, which is a definition of the semantic data layer. Could you just talk a little bit about this slide here, Dave?
Sure. I want us to view semantic layer in three contexts, and each of these is a little bit different view of it. If you have experience as a data modeler, think of this as somewhat similar to the conceptual, logical, and physical context for data modeling. So at the highest level, the conceptual and semantic layers, I want to think of it as purpose. A semantic layer is a data management concept. It is conceptual. Its purpose is to separate data meaning from data structure. And by separating data meaning from data structure, we can associate that common meaning with multiple disparate, sometimes duplicate, sometimes inconsistent data structures. So at the conceptual level, it is a means to capture the data meaning without having it tightly coupled with the structure. At the architecture level, which I would equate with a logical model in terms of layers of abstraction, a semantic layer is an architectural component. And this is one of the things that I think is most strongly needed to be recognized, and maybe not as thoroughly recognized as it needs to be. Semantic layer is first and foremost architecture before it ever becomes software. And a good data management architecture will have multiple semantic layers, maybe all relying on the same semantic model, maybe relying on different semantic models, but multiple semantic layers within a single data management architecture. Then the third layer is semantic data layer as a software component. And the purpose of that software component is sort of that mediation between how the data is stored and structured and what it means in business context. So now back to the opening question, Michelle, that software, that semantic layer inside a BI tool is one implementation of the semantic layer. It can be a software component, but we don't have to implement semantic layers only with those embedded things in BI tools. So really three different views of this. And if you're moving into the world of semantic data layers, start with the idea of purpose. Understand what things you want semantic layers to do. Then look at your data management architecture and ask, where do semantic layers fit to satisfy those purposes? And then you're positioned to think about, now, what kind of software components do I need to actually implement those layers?
Yeah.
So
with this talk on semantics, I could see, data governance professionals, I'm sure, are thrilled to be hearing people finally talking about the semantic data layer with all the opportunities around not only using, getting back to that tooling conversation, but also how are we informing AI? How are we talking about semantics in the business? And when I started learning about data modeling, the first book I picked up was Kimball's Data Warehouse, and he talked a lot about the enterprise-wide ambition and thinking more about the separation of semantic data layers. If you're thinking about them in the business context, are you thinking they're domain-driven decisions and the semantics are separated by maybe business units or use cases that the business wants to answer?
You're going to find multiple levels of this thing too. You're going to have semantics, local terminology, local lexicon within financial management. You're going to have local language within sales and marketing, within human resources management, within operations. Each of those are going to have their own local dialects, and there's going to be some overlapping concepts across them. So I may need a semantic layer that describes the meaning of financial terminology, and one that describes the meaning of HR terminology, and one that describes the meaning of operations terminology. And then I may need to map some components of those semantics to a higher level that is an enterprise level.
Okay.
And that's going to sort of align with what we talk about as master data, the core concepts, the core ideas. So this is again why we need multiple semantic layers, and each one is a translator.
Great. Thanks for that overview and follow up on those questions. I'll bring us to the next slide here. And I think this is kind of what you're touching on, is the different kinds of semantic data layers and how they might relate. So could you give us an overview here?
Yeah, this is exactly what I was trying to touch on. So at the highest level, we have two kinds of semantic layers in terms of what they are trying to accomplish. We have definitional layers. Their purpose is simply to define meaning, to assert the meaning of the terms that we use in data. Then we have application layers. Their purpose is to put that meaning into action, to actually apply the meaning. So that highest level of definitional layers is the enterprise or core layer. And it's that shared stable meaning for the data concepts that cut across several domains. Again, I want to equate it to what we think of when we talk about master data management. It's those things that are widely shared across business functions and business processes. So it's a limited set of data, and it is things that do affect many different areas of business and many different areas of systems. Going back to Kimball and the Data Warehouse Toolkit, this has some fairly strong alignment with conformed dimensions. Yeah, it's very, very much the same kind of idea. We're not trying to conform all of the facts in the fact table. We're trying to conform those dimensions that are used across multiple star schema. Okay. This is at a high level that same kind of concept. The next layer, the domain layer, lets me get to the local meaning. Now I have a domain layer for the financial domain. I have a domain layer for the operational domain. I have a domain layer for the HR domain, and so on. So those are with specific business context. And this begins to be helpful to me, especially in that operational world when I'm dealing with SaaS applications, and Marketo has a different lexicon than Salesforce, has a different lexicon than Workday. And I don't get to go into those systems and change their language to fit my business. One of the challenges we have in this operational data world is we now, instead of building our own internal systems, collect commercial software from many different sources, and we're trying to make the data fit together. And part of making that fit is connecting through semantics. This is where data interoperability really comes into play significantly. So we need to define the meaning at an enterprise level for a small set of things, the core layer. We need to define the meaning at a functional or domain level for in greater detail. Then we can put those semantic layers to work, those semantic models, with an integration layer that is when we want to take data from multiple sources and combine it as something that we're going to store as a new copy of the data, warehouse or data mart, or present it in the form of a view. That's what the data virtualization tools are doing. So this is really more in the integration layer where we would see an alignment with data virtualization. Then we can have an enrichment layer. And this enrichment layer comes into play when we're bringing in external data or when we're deriving new data. So in some contexts, one simple example would be geocoding. I have physical addresses. I can connect to geocoding databases. I can geocode, which gives me lots of new query capabilities. But if I don't define the meaning of the geocode data elements, I've lost something. So another example that is going to be more common for more people more frequently is in feature engineering, preparing data as features for AI to act upon. And when we take data from all of those various sources that flow into AI data preparation and do feature engineering, and we're doing dimension reduction, and we're doing feature normalization, and we're doing all of those kinds of things, we are deriving new data. If we're deriving new data for AI models to act upon, we better define what that new data means. And then finally, we've got a consumption layer, another way to apply meaning, where the ideal situation here is semantic query. Business people can query data using business terms instead of obscure technical terms. So 5 kinds of semantic layers, each with different purpose. And again, underscoring the idea that I need to have multiple semantic layers to make this work.
Awesome. My question on this one is for Carlos, actually, and how to apply this. So say you're engaging with a stakeholder on a new project. You know you don't really want to try to boil the ocean and capture this all at once. But what if they say to you, let's build the enterprise semantic layer first? What kind of a conversation would you have with them?
Yeah, normally we try to break it down, I would say, to start with a high impact, high priority area that we could get a lot of value with early on. Sometimes in a lot of companies, that could be the finance area, but it doesn't have to be. It could be an area that they've been struggling with a lot too. So the domain would be somewhat narrow, I would say, to make it successful. We would focus on the consumption layer. In fact, probably start with how are they going to consume the data and what do they need, and ultimately decide what the integration and enrichment layers would look like, in between. So I think kind of almost I like to say a right to left approach, except you do need to pick the domain you're going to work with early on for business purposes and use cases, but determine what consumption is needed, then determine how you're going to integrate and enrich the data, and what is that layer going to look like to the end consumer, the end users.
Yeah, and probably throughout to make sure you're, even if you're starting small, making it flexible and scalable, starting to have those conversations on how does the enterprise view this to start piecing together that left side as well.
The right to left approach also makes a lot of sense because you can't do this without engaging business people.
Yeah.
And the number of stakeholders grows as you move from right to left.
Mhm.
I'm going to move on now to the next slide and getting into semantic modeling with graphs. And here I want to ask about, there's a whole world that I'm not even totally familiar with on formal semantic modeling languages. I've heard of, I think, OWL, SML. But from this image here, Dave, you're not pointedly using any single one of those. So could you describe what you're representing here?
Okay, so semantics is best expressed as triples. A triple is an assertion in the form of subject, predicate, object. So customer contracts rental is a triple here expressing something about the vehicle rental business. Rental provides vehicle is another triple. In the first example, customer contracts rental, customer is the subject, contracts is the predicate, rental is the object. In the next example, rental provides vehicle, rental is not the object, it is the subject. Provides is the predicate, vehicle is the object. Okay, so if we can express semantics in this way, it becomes very clear, simple assertions of truth, of fact, about the meaning of the terms we're using when we talk about data. I like graph modeling because it is visual. When I first started working with semantics, I learned RDF and OWL and some SML, and I thought, this is code. I can't model with business subject experts in stuff that looks like code. I need it in a visual form. I need it as relatively simple. So if you take away all of that stuff that lists rental ID, rental status, vehicle cost, etc., and just look at the core image, that's what's known as a knowledge graph. What we know about this business. Customers contract rentals, rentals provide vehicles, rentals require payments, customers make payments, etc. We can extend the knowledge graph to become a property graph. That is, what properties do each of these things have? What facts do we know about them? And this is the process by which we can identify the things and begin to describe the meaning of them. Now, this is just the diagram. Ultimately, I need to put definition and description behind every term in this model. But the process of developing the semantic structure is one of working visually with the people who have the business subject knowledge to put this visual together.
You know what I like about this, Dave, is it makes me feel like I'm 18 years old, because I think when I took my first data management class in college, we did diagrams like this. And over the years, business just overlooked this, right? It just skipped this step, right? Very often.
Yeah.
And now we're seeing how important it is. It was a great concept that in business, most people just decided we just didn't have time to do this type of work. And now it's coming true that it's the world of data is just becoming so broad and complex that it's necessary. It's just a must.
Yeah, we don't have time not to do it.
That's right. Yeah. Yeah.
Yeah.
And here, yeah, this knowledge graph here is a great visual of bridging the gap between, the engineers, the architects, and the business. And then I'm going to move on to the next slide, ontology and taxonomy, so we could start discussing the relationships between. So Dave, do you want to give us an overview here?
Sure. So these are the two basic constructs in semantics. Ontology describes a set of concepts and how they're related, and that's what you see with customer contracts rental. Rental provides vehicle pickup at location, return to location, and so on. That describes a set of concepts and the relationships among them. Taxonomy describes classification structures. In this case, we see rental as reserved rental, active rental, completed rental, terminated rental. If we approach these things semantically, in a business scenario, someone might be confused about what's the difference between a completed rental and a terminated rental. Okay. If we define the meaning of these terms, we learn that a completed rental is one that ended normally with the vehicle being returned as scheduled. Terminated rental is one that ended abnormally due to an incident such as an accident or a traffic violation that caused the renter, the driver, to be arrested, or, so a terminated rental results from an incident. A completed rental ends normally. As I'm doing this kind of modeling, and there's not room to show it here in this time frame, but what would happen is when I begin to define terminated rental and understand that it occurs as a result of an incident, the incident becomes another node in my ontology, and I have to ask, how is incident related to the other things in the ontology? So this is sort of how the semantic model grows, by working back and forth between these things. Now, the other thing about taxonomy is we think in terms of AI, is these classification structures are the labeling that we want to use when we're undertaking supervised learning, when we want AI to categorize things in context of categories that we've already defined. That's what taxonomy is all about. If we're doing unsupervised learning, it may surface new categories that we may want to feed back into our semantic model. But yeah, ontology and taxonomy. How are things related and how are they classified? That's pretty much the basic constructs for semantics.
Okay, and then on the next slide, you put it all together by further defining the relationship. So let's continue with that example and take us into this slide.
Okay. And the goal here was just to show how much information ends up being collected as we do this kind of modeling. So I've got the original model, customer contracts, rental provides vehicle with location and payment in play, and I've got the properties for those things. And then I've got taxonomies, because when we talk about rentals, sometimes they're a round trip, sometimes they're a one way, and different rules may apply to those. So it's noteworthy here that it's not just things, customer and rental, that may have taxonomy. It's also relationships, customer contracts, rental. It's the relationship contracts that has subtypes. It's also noteworthy that relationships can have properties. Vehicle pickup at location. The pickup relationship has a date and a time. So unlike our traditional data modeling, entity relationship modeling, where relationships don't have properties, relationships don't have subtypes, in this kind of model, they do. So we're able to better express the realities of the world in this sort of model. Now, what you see here is several taxonomies. Payment, requested payment, received payment, declined payment. Those relate directly to, if you look at the properties of payment, we have a payment status. So as you're doing this modeling process, if you find properties with names like status or type or class, those suggest that there's taxonomy in play. There's a classification structure somewhere. And if we really want to understand the meaning of data, we need to dig in and explore those classification structures. Without using too much time, probably the other thing I want to say is these subclasses make sense when they have different properties and or different relationships than the superclass. So you can see like terminated rental has a relationship to incident that doesn't apply to all rentals. And you can see that reserve rental, active rental, completed rental, and terminated rental each have different properties. So this gives us a mechanism to sort out business relationships at that classification level and at that properties level, as well as at that higher level of the triples. So this just shows how much information can be collected in a model of this kind, how they grow.
Yeah, this is awesome. And I'm just curious if anyone who's listening in anyone who's built a knowledge graph or an ontology, if you've also used classified or classifications and relationships in your modeling at this phase. So if you have or have not, would love to hear about that in the chat. We've also got eyes on Q&A, so if you have any questions for Dave or Carlos, please drop them in there.
And we do have a few questions, Michelle. Do we want to take them now
Yeah,
or wait till the end? Okay.
yeah, let's
let's
pause here.
Mariano asked a couple of questions, so I'll paraphrase them and kind of combine them. But he's asking, is data lineage considered part of the semantic component as well? And he's also asking, is this a big evolution of the old universe concept of business objects?
Okay, I would say it's not about data lineage at all. It's about data meaning. And the important thing that a semantic layer will do is let that meaning travel with the data as it moves through pipelines. But the semantic layer isn't trying to capture or record data lineage. In a sense, this is sort of an evolution of the business object universe. It's another way to try to express the meaning of data and allow data to be queried, addressed, handled, processed, understood from a business context instead of a technical context.
And let me ask another question from John, who says, good topic. I fully agree with the separation of meaning from structure, but he also wonders if we considered whether the semantic layer can extend beyond data to upstream business glossaries before existing or new data structures are considered.
That's an interesting concept, one I've not considered. There should be some very strong connection as this whole field matures between business glossary and semantic model. The two should be highly compatible, and perhaps the business glossary, because behind that knowledge graph, property graph diagram needs to sit definitions of all of the terms for us to really have fully documented meaning. So that would be the strong connection to business glossary. And then I'd think which comes first, business glossary or semantic model, is a question of project demands, project priorities.
Well, thanks for the answers. Why don't we do have a couple more that just came in. Why don't we save those till the end, Michelle, and go continue through the deck?
Okay. Yeah, sounds good. So we're going to look at here, and I know you said earlier on that oftentimes when we're looking at analytical data architecture, we might neglect the operational data architecture. And this is an image of a fragmented data management system. I'm wondering if this slide is representing what that neglect might look like.
Yes, a portion of it represents that neglect. What's happened in operational data architecture is we've paid little attention to it for 30 years while we've been focused on data warehouses and then data lakes and then data lake houses. And now feature stores, prompt stores, model registries, and the beat goes on. And during those same 30 years, we've gone from building our own custom applications where there was at least some cohesion to buying SaaS applications from multiple vendors, ERP applications from multiple vendors, trying to wire in some of our old legacy apps so that we get all of these applications with different dialect, different lexicon, different semantics, and difficulty connecting them. So what you see in that upper left corner is lots of data silos talking to each other through point-to-point data feeds. And that's the operational architecture neglect. Every time we need one application to talk to another, we build another data feed. I would be happy for anyone who has a complete inventory of all of their point-to-point data feeds and knows what data is contained in them. I'd be happy to hear from you. I don't think there's anybody out there that way. This is the mess we have in operational systems. What we've done to try to connect the dots for analytics is ETL, moving data to data warehouses, operational data stores, and data lakes. And all of the data equivalents, let's say equivalents between marketing data and sales data that are stored differently, encoded differently, and named differently, all of the equivalence is embedded in ETL code. And every time that integration needs to happen in a different ETL process, I'm betting that it's somewhat different in the transformation more often than it's consistent. So we're propagating in some ways data disparity. We avoid it with data warehousing when we force fit data into a rigid schema, but sometimes that force fit is really something of a misfit. So this is fairly typical of what we see in data management architecture today. Maybe the thing that's not typical is that there's only one data warehouse, because the recent polls that I've done, most organizations have somewhere around 4 or 5 data warehouses through false starts, through new undertakings, through rogue data warehouses, through mergers and acquisitions. Most organizations have 4 or 5 data warehouses, so it's really even messier than this.
Yeah, it seems like that would be an just fragmenting exponentially as you pull in more data warehouses into the mix. I'm going to move us
Yeah,
on here because
yeah,
we have more questions to hit at the end, and I want to make sure you've got plenty of time for your payoff slide, Dave, which I looked
okay,
ahead. I think it's going to be data interoperability. But
okay,
tell us a bit about the cohesive data management structure on this slide.
okay. So here I'm trying to bring in some other concepts, because one of the points I want to make is that semantic layers all by themselves don't solve these problems. So what's been brought into play here? Domain data management. I'm not saying leap off full-blown data mesh. See, you can if you want. Hold your nose, trust your cape, and jump. But if we think of this mess that we have in transactional systems and begin to bring some of the concepts of domain data management into play, we can simplify the point-to-point data feed mess. Maybe I still have point-to-point stuff going on between marketing and sales. Maybe I still have point-to-point stuff going on between inventory and purchasing. But when sales wants to talk to inventory, I can do that through domain interoperability. If I put a semantic layer in place, a sales domain semantic layer, and an inventory domain semantic layer, and I map them to common semantics. So that's one way to do this. Another thing that I brought into play was data products. Data products organize, collect, structure, shape, process data in some specific context. That specific context can be described semantically. So the idea here is, if I want to position my architecture to get the greatest advantage from semantic data layers, I also want to rethink my architecture and ask, where does domain data management fit? And where might data products fit?
Great. And I think this one is also highlighting um, the different domains as well as the interoperability. So could you pull that into the mix here and talk about what you're highlighting?
Yeah, exactly. Each one of these colored bands represents a semantic layer. So we've got domain semantic layers, the 5 types that we looked at earlier: domain, shared or core, integration, enrichment, consumption. Each one of those types of semantic layers comes into play here. So each of those transactional system domains can be wrapped with a semantic layer for the domain.
Okay, and then we talked about, the right to left approach, and I'm guessing what the easiest start that an organization would have was to focus on maybe one of these domains, one of these use cases, have that consumption in mind, have the enterprise view in mind, and then build it out to be flexible and connected from there.
Yeah, you wouldn't want to try to build all of this at once. But if you take, like Carlos said, often financials is big pain point and big payoff point. So maybe you start out building the semantic layer for the finance domain. And once you have semantic layer for the finance domain, then maybe you're in a position to build finance data products. And that gets us in a position of sharing financial data without it all being ETL and point to point. If I build data products, I can also wrap them with a consumption layer.
One thing I see in this slide, Dave, is that when you do this, it makes almost all the data consumable, right? And
Yes.
by definition, trustworthy. Whereas often you might not consider some of this data consumable by end users or analysts. It puts you in that spot where it puts you in a spot where everything can be consumed almost.
Right. And that's a lot of the value of these semantic layers is it's consumable without having to get down into the weeds of how it's physically stored.
Mhm.
Yeah. And so that
Yeah.
is the
You don't have to be a SQL expert, right? Is
right.
really what we're saying. And I'd like to say now, I think in the future, and the future is not very far away, we may never write a SQL query again. We'll query a semantic model, not
Yeah.
a SQL engine.
Yeah, that's a good vision for the future. Um, what I want this particular slide or sequence of slides to illustrate is that if you're a data architect, you need to be thinking about what your architecture should look like in 1 year, 2 years, 3 years. Gartner puts it at 3.5 years, 2030, that semantic data layers will be as critical a part of your infrastructure as data platforms and cybersecurity.
Mhm.
Okay. So if you're a data architect, you need to be thinking 3.5 years out now. How are you going to have semantic layers as a critical part of your infrastructure? And that's this evolution, and it's understanding that it's multiple semantic layers with different purposes: domain, shared, integration, enrichment, consumption. And where do you place each of them in your architecture? So
Mhm.
as a data architect, step back and draw a picture of today's architecture and ask, where does domain data management fit in? Where do data products fit in? Now, how can I bring semantic layers into play? That's my story, and I'm sticking to it.
Mhm.
It's a good story. Let's move into the implementation patterns here now. And you have 4 different implementation patterns listed out with different strengths and limitations. Um, rather than talking about each, can we talk about when a team's picking which of these implementation patterns to go through with? Um, what are some common mistakes they might see?
Probably the most common mistake is picking the wrong one. And some of that is just common sense. If I'm building semantic layers for data products, API is a natural fit. We interact with data products through APIs, so API is a natural fit. If I'm new to building semantic layers, and I'm first trying to support just easy business access and understandability of data, metadata only is a good first step. It's easy to build a metadata semantic layer and then evolve it to API-based, federated, or graph-based. If you already have graph technology in place, if you have Neo4j or Tiger Graph or Anzograph or one of those technologies, you're already in a place where you could be building graph-based semantic layers. You have the technology to do it. If you're doing the modeling as graph models, it's a natural step. Go ahead and implement those graph models in that graph database and begin to make them active. So it's thinking through where you are, what you know, what skills you have, and what you're trying to build. If you're building data products, go to API. If you have graph technology, go to graph-based. If you have a virtualization tool, if you have Denodo, go ahead and use Denodo semantic layer capabilities. So I can't give an absolute do this, don't do that so much as to say, think in context of where you are, what you have, what you know, what you need to learn, and work with it that way.
Great. So if you can clearly define the primary need you have, this table will tell you where to start. And I think that goes along with your next slide as well. If you've got maybe several needs that you're trying to meet or accomplish, you might want to combine some of these patterns.
Yeah, you can absolutely combine some of these patterns. And again, I think just like the right to left thinking, top to bottom thinking sometimes can make sense. Start with metadata and then maybe go to virtual or graph based and then push that to APIs. So start small and learn and grow. Um, if you're trying to accomplish semantics embedded in applications, don't go to virtualization because it's weak. If you're trying to accomplish API based or data product based interoperability, data mesh, for example, then absolutely go to API based because it's strong. So,
Great. And we've got about, let's see, 7 or 8 minutes left. Closing out with our best practices for data semantics, as well as Carlos, do you want to see if there's any other Q&A questions that we want to answer?
Yeah, we do have a few more questions. So Dave, why don't you cover this slide? Then let's go to the screen chat where we show Dave's book, and I'll ask the questions while
Okay.
we do that.
Sounds good.
okay. So the first one is pretty obvious. Define the terms clearly, consistently, use shared definitions. Just doing the graph model and having those terms without defining them isn't good enough. So make sure that each term, every label on that graph model has a corresponding definition. Start with business concepts. Don't try to reverse engineer semantic models from existing data. That gets really, really messy. And really, the thought process just reflects the convoluted mess we have already. So start with the business concepts and work toward the data. Don't start with the data and try to work backward. Separate the meaning from the implementation. Semantics is about the business. It's about assertions of fact relative to the real world. And the systems and the database schemas are just artifacts about how we've chosen to represent that real world in technology. So keep them separate. controlled vocabulary is really valuable. If we use language consistently and clearly and meaningfully, and we standardize those names, we get better communication. The more that we can make those terms, that vocabulary, business language, not techno-geek language, the better job we'll do of building semantics. Explicit context. Meaning varies across domains. We talked about this. Financial management has its lexicon. Human resources management has its lexicon. Be clear in each semantic model and each semantic layer about the context. Let semantics guide the integration. So if you're still going to do ETL integration, and I'm not saying don't do it because there are times when it is valuable and helpful. One of the things I need to point out is that data interoperability isn't going to give you historical records that a data warehouse does. It will interoperate however much history is in those source systems, but it's not going to build a historical record like a data warehouse does. So it's not a replacement for integration. So it's another tool in the toolbox. So expect that you will continue to do integration, but you can use these semantic layers to help drive integration and ETL processing that is consistent regardless of how many ETL processes need to integrate the same data in different ways. Semantics applies at the boundaries. APIs as the boundaries of data products. Domain boundaries for domain interoperability. So semantic layers apply at boundaries. If you think back to that last architecture diagram, every one of those colored bands that was a semantic layer was at the boundary of something. So when you think architecture, think about placing your semantic layers at boundaries. Don't hesitate to mix implementation patterns, metadata graphs, APIs, and virtualization all can come into play. Design for reuse, expect change, and back to the right to left ideas. Start small, deliver value, learn as you go. All of those things are important steps to getting where you want to be.
Awesome. And I really want to promote this book here. If anyone in the audience is interested in this topic, Dave has written an incredible new book on data interoperability. Dave, what do you want us to know about this book before we grab it?
It places strong emphasis on the operational architecture neglect. It gives you basic framing of how to get started with semantic modeling and using graphs to express ontology and taxonomy. And it gives some guidance of how to think about this. Is mostly an architectural book. So it doesn't go deep into implementation, but it places interoperability in context of data management architecture as one of the important steps we need to take. It addresses one use case for semantic data layers. Interoperability is only one use case for those semantic layers. And there are many more, but data interoperability is an important step in the direction we need to go.
Well, thanks a lot, Dave. I'll follow up and just ask you a couple quick questions. We only have a minute or two left here, and of course, people always ask if the slides in the recording are going to be available afterwards, and I know they are, but I'm not sure. I think they get an email afterwards, and
Yeah.
we give you a link to the recording, so you will get the recording, and I believe the slides as well. So that will be available. So let me kind of combine a couple of questions here that we got. Talk about semantics versus context. What is it? What is semantics versus context? And another question, is there a connection between business glossaries and technical glossaries? And I think we'll end there, but those are the final two, if you can munch on that a little bit.
Okay, semantics is a description of the meaning of things in the real world. Context is the scope of real world that we're trying to address. So semantics may be the meaning of things in the financial management world. Context is financial management. Semantics may be the meaning of things in healthcare payer world, healthcare payer industry. Then context would be that healthcare payer industry. So context can be as small as a business function, as big as an industry, or lots of levels in between.
And the final question was a business glossary versus a technical glossary.
Business glossary versus a technical glossary. I think there's a connection, but they address different audience. And
Yeah, and I guess that's the question really. Is there a connection between the two? Not really versus one versus the other.
yeah, I believe there should be a connection between the two. We should be able to trace either direction from business meaning to where is this meaning implemented as data, business glossary to technical glossary, or from technical glossary or data implementation to what does this mean from a broader business perspective. So there should be a connection and traceability both directions. Good questions.
Well, thank you. If you want to reach out to Dave, his email's down here on this slide. Please grab his book. If you have any questions for Datalere, Carlos, or myself, or anyone on our team, if you'd like to get involved or speak at a future webinar, please reach out to us, info@datalere.com. Dave, it's been an honor to talk to you and been reading some of your stuff for a while now, so great to meet you. Carlos, as always, thanks for being on, and we'll check you guys out next time.
All right.
Thank you
Thanks,
very
everybody.
much, Dave. Thank you.
Thank
Great
you.
session.